So again, here's the typical imports and whatnot. And up here, loading clip. This is just sort of a helper class that it's not really necessary. It's just some extra helper functions to make all the clip embedding stuff easier. Just reorganized compared to what's in the diffusion notebook. And here's
so Daniel, what is different about this compared to earlier collab?
So this one is going to be optimizing deep image prior with I think this was pioneered by Catherine. I don't think she ever released code for it, but it's really, this is an example. Like, I want to show this because it's an example of how, like, the things that you learn in the other clip guided notebooks or anything like that can be cross applied to different models. So this section is just defining clip and how it embeds images and text. And then here is the familiar make cutouts function again. This one is mostly the same. It's using Cornea this time instead of Torch Vision. In case anyone's curious, Cornea, if you can apply it to the whole list of cuts, and it will make a complete random augmentation for each of those. Whereas if you use Torch Vision, you have to apply the augs each time to each cut. I guess you have to apply the augmentations. Otherwise, like the entire batch will have the same augmentation. Like they'll all be rotated this way and this color and whatever. Cornea handles it all at once at the end. So that's why you see that's different between this and the diffusion notebook. The diffusion notebook was used in Torch Vision. Otherwise, it's the same. Okay, clips loaded. These are some helper functions for displaying things. Image grid just puts together the batch into one big image. And this here, this display image function, unlike the display.display that you'll see in a lot of these notebooks, which will output, it'll like print it right below the cell in collab. I'm using CV2, or also known as like Python-OpenCV, I think, which will create windows locally for me. And it's a lot faster than printing it out. So that makes it, a lot easier to iterate on this stuff. So here, I didn't really cover this in the last one, but spherical distance loss is sort of, this is what gave us the distance between the clip image embedding and the text embedding. You might see in some clip guided notebooks that there's, instead of spherical distance loss, people use torch cosine similarity. This is this was the way that it was done. I mean, like, people interchange with these two, they're pretty similar. Spherical distance loss is just supposedly more correct because it takes into account like the big hyperdimensional sphere thing. It's a different kind of distance calculation that's maybe more accurate. Works for me. So here is the loop for, here's the iteration loop for deep image prior, and it's not much. What you'll see is, so like in the diffusion notebook, we had, in the diffusion notebook, the way the output gets to us is through a really weird, like, it's not weird, it's just kind of hidden behind the scenes. It's within the code that gets us these values isn't seen in this notebook. It's within the code of the repo, the guided diffusion code. But what you're seeing here with like out and like this value here is sort of equivalent to here. This is just, but it's way simpler. All we're getting is, give me the output of this network, this deep image prior network I'm training. And this is the noise This is a noise that gets put in.
Mm-hmm.
And then from the output, we go embed that image with clip. We get the loss, the spherical distance loss, just like before, between this current image embedding and the target prompt, and then run that backward. So this is using a normal optimizer, not AutoGrad. So you'll see things like dot backward and optimizer dot step and whatnot. This code right below, so it calculates the loss, runs it backward through the network, and displays the progress. And this code is a little bit roundabout. A lot of this is really just defining different optimizers. So like to make things simple, this is really what it is.
Mm-hmm.
Or you could even this, if you just put this anyway. So it defines an optimizer, an atom optimizer in this that's pretty common. And then it loops over the number of iterations, zeroes out the optimizer grad, runs this code in the closure function to get the loss and returns that loss, and then the optimizer steps. You'll see this sort of thing in most non-diffusion notebooks. And that's it as far as the as far as the optimization goes. So you'll see it's really similar, and it would be more similar to things that aren't diffusion. Like I know this is two very different things, but a lot of this stuff you can practically copy paste from one notebook to the next once you know, once you get a good feel for how this works. And the only thing you're changing out really is how you get your network output, because that's all that matters. Just how do I get the image out of something, and the rest is all the same cutouts, the same everything else. And then here you can see where the deep image prior network actually gets set up. So this is just the seed setting again. This getNet function was imported from the deep image prior repository, and it just initializes a deep image prior network with, I think, just random initialization. And these are just some parameters that I won't get into. It just sets up like the different sizes of the layers of the network and how many layers there are, and different things like how they upsample and downsample between each layer and all this neural network stuff. Once you have that network, you get your starting noise. This is the input that's going to go into the network. And so that's about it. I mean, this cell just sets up the network and sets up our noise that we're going to be putting in. And this is the size of that noise, basically. And the size of the noise reflects the size of the output we're going to get out. And so we're going to run for 350 iterations. You can mostly ignore this for now. There's this gets applied, if you saw in the closure right here, right before the steps, right before the input gets put into the network to get the output. It applies a bit of random noise to it. I tend to turn this off because at least I found for the clip generation, it wasn't useful. It seems to be useful for what you're supposed to use deep image prior for, like image restoration. But here it just sort of wiggles. It just wiggles things too much. It doesn't really help. So that I have that set to 0. I'm going to do 16 cuts. I set up an instance of the make cutouts class, and here's I'm going to use the madgrad optimizer using this learning rate, and anneal LR means it's not gonna. If I had this set to true, then I just have a schedule where it slowly drops the learning rate over time, because it can be helpful to have a very high learning rate at the beginning and then drop soon after. And so you could make some big steps, and then after get more to finer detail. And here's our text prompt. And here I have display all x true. We're going to see what those augmentations look like when I'm running this. And the rest of this is just like setting up whether to save a progress video and running it. There's something I was going to point out. Oh, never mind. Not sure what it was. So I'm going to run this. Hopefully it works.
I'm just amazed. How do you find time to like play with this many parameters and like you need have trial and error? Oh.
Just too much time. Um, I don't know. It feels like it's just my life now. But there was a point. There was a point where, like, when I really got into this stuff in the summer, I had sort of triggered something mentally for me, and I had to take a break from work. And that's when it really set into stone. Like, this is what I'm going to be doing. And of course, taking that break from work, like, I was even more into all this, barely sleeping, not very healthy. But
Because
yeah.
I remember like those Discord channel, like even at late night, like people were posting their art generation in that Discord channel, and like, dude, are people sleeping? It was like a crazy
It,
atmosphere.
and it changed. It changed, right? Did you notice that it changed a little bit? Like, well, I don't think you'd. I don't know if you've been visiting that particular Discord much since back then, but like, it was really intense during the summer,
Yep.
wasn't it? Like, a lot of people were in the same situation as me, except some of them didn't have a break from work. So, but yeah, I would be up working on the stuff, putting out the output, and then seeing people go to sleep, and then still being there when they wake up again. And it's like, hey, how was your dreams? I've been dreaming with Clip.
And by the time you check the Discord in 2 hours, there are like 5,000 messages and like.
Yep. So here, so is this displaying at all?
Yeah, I see the cutouts as well as the final iteration.
Okay. So this I was optimizing towards a moody painting of a lonely duckling, right? And you can see, I'm gonna restart it now.
But your GPU is truly showing the speed.
So here you can see where it started from nothing and it's slowly going towards the duck. And over here, here's all the different angles. You can see the grayscale getting applied. You could see some color jitter getting applied. And it might be hard to track, but sometimes you can notice that they're cut out. Like, you can see it's really close to the, I can like hold this, I think. Yeah, so if I hold it, it'll be paused. You can see like how some of these are zoomed in, some of these are full, some of these are perspective shifted. Having those cutouts is also useful for, like, even if the image isn't that big, getting small cutouts allows you to like pack in more detail anywhere in the image. Like, even if you had something that was 224 pixels, you might actually want to size that up and then cut it, because that way, like, Clip gets, just sort of more fine-grained into all the little areas. In this case, I'm not scaling it up. So you'll see, like, most of the like crops aren't that intense. Like, they look like maybe like 1/5 the size sometimes. Like, it'll zoom into this signature here or something. But yeah, so I had set something like this up very early on in the like BQGAN, maybe before BQGAN days, because I think Ryan had one in the original like Big Sleep notebook. Maybe it was an option. I can't recall which of his notebooks, but it was like, it would print out one of the augments every once in a while. I wanted to see the whole grid, because that's the only way to really get like how much variety is Clip seeing. Otherwise, you'd have to like pause each time, make sure like compare each individual cutout or whatever. But yeah, having this was super useful because there's a lot of torch vision augmentations out there. I'm using some subset of them. Some of them aren't useful at all. Some of them won't do what you expect. Like there was this one that was supposed to add a particular kind of noise. And I found that it was, I don't know, no matter what parameters I set, it was really intense noise. Like the entire image was just noise, no matter what I did. And if I wasn't displaying them like this, I wouldn't have known. I wouldn't know what's wrong. One time I thought that my images were being cut out, but they weren't really. Like almost every single time it was the full size image. And that's something I really wouldn't have ever known, without looking. Like with the noise thing, I may have seen like, oh, it's not really getting very far. But with the cutouts one, I couldn't tell until I looked at it. Or like when I mentioned earlier about torch vision versus cornea, that's how I realized like just how different it was by displaying it like this. Because when I used torch vision and applied it to the whole batch, it was just like every single one of these was the exact same thing, basically, which is useless.
So this is like the crux of figuring out like a lot of possible like codal like things that might go wrong in a code. Like this is a good way to test check.
Yeah. Yep. And like, so like, let's say you wanted to do wide images, right? This would be a great, looking at the augmentations would be super useful for that, because like, I don't know if you remember, but a lot of the earlier scripts, especially if you try to use something wide, it had issues with composition. Like either you would have like duck and duck on either side, or like the entire, like this side would be really defined, but not so much over there. It depended on the cutting strategies that people had. And then even if you did have it cover the whole thing, then there was the issue of it would just look stretched often. Like especially a lot of the earlier ones, a lot of people's results look stretched, and it was because they were trying to force clip to see the whole thing and not just like get it all segmented out. But there's like, so I don't know, I think I have it in here, right? So I have something in here where if the width is not the same as the height, then use random affine to shear the image. So it's not gonna rotate it, it's gonna shear it, which is like, it turns into like a trapezoid, kind of. And if this still works, is the way I remember it, it should, like, if you have a long image, it should try to sort of trap.
Yeah, I know.
Put a little bit to try to fit as much into a square. Let's see if that works. So what we're looking for, is working. It might be working. I'm not sure. Okay, here's an easy way to check actually. Turn off all the other augmentations. Because the random perspective augmentation here is making it really hard to tell.
Yeah.
So that's the one that's making it like, yeah. I'm gonna turn that off, and this, and this. All the ones that changed the position of it turned off. I don't know if I have that value set right. Yeah, I'm not sure if I have that value set right, but because I remember it being quite obvious when I've looked at this before.
Yeah.
So I don't know. But generally, you would hope to see that like the whole thing was there, just sort of instead of squished, you would hope that it's like sideways and long.
Correct.
Sort of, yeah. But here you can see the cutouts in action a lot easier without all the stuff moving it around. So this is where it crops in. And right now it looks like it's sort of turning out like that double composition where there's like one duck over here and one duck over there. So there's something not quite right. Oh, well, also all the other augmentations are off, so the result's going to be a little bit worse in general. But yeah, that's one way to check. And you could like do set that shear up to like 45 maybe, then we could see doing anything. Yeah, okay. In some of these, I'm seeing it obviously happen.
I saw some shear.
Yeah, there's some going on.
But maybe the crop size is like not the right proportion. Like it's square and we are viewing rectangle, so it's taking the minimum.
Yeah, maybe if we saw, I think if we saw the pre-crop version, that's like, because really what we want to do is shear the pre-crop version for the most part, because I mean, yeah, I don't know, that I don't think it matters too much that each individual crop, wouldn't cover the whole thing, because each individual crop never covers the whole thing. But yeah, these ones in the bottom right that you see here are a set that are always the full size. That's why you see that these aren't changing much, because sometimes you want to make sure that at least some of your cuts cover the whole image, so that it keeps some composition in mind while also getting a look at the smaller details. And this is all anthropomorphizing by saying like looking at it, but it's like the easiest way to talk about it. It's more like it's taking an average embedding of all the little tiny crops and making sure it all aligns with that text prompt.
This is like out of like I love it. Like this has been a great session. I know it's like getting a bit late there, so we could wrap up.
Yeah. Oh, yeah, yep.
Unless has it seen my image? Like,
has it seen? Does it know you? Oh.
No, like you wrote my name as prompt. So I was like,
let's see. You're a mystery. Wow, what? That sure is something.
It's getting very trippy.
Yeah. Oh, I was going to point out just one thing. When I said that the diffusion models are really great at composition, that's one of their 4 points. You may have seen well, I'll just share an example here. This is a generation for the prompt, A Young Empress by Yasutomo Oka, a photorealistic portrait of an empress. And this is in the fusion, and it very commonly properly puts, it's a face, it's a portrait. When I try the same prompt with deep image prior, which doesn't, oops. Oh, right. So this continued from the last one. That's pretty. Let me start over. You'll notice, at least when I tried this earlier, that the composition will probably be a bit weird. Oh, okay, this one's not too bad. When I tried this just before the call, I found it just drew a bunch of flowers over her face. It wasn't, it wasn't a great composition. This one's not bad, but
random seed worked out here.
Yeah,